Hello everyone, hope you are doing well. So as we started collection, right, the first video we have seen what are the different type of collections we have, right, collection hierarchy we have seen. So today we are going to start from the list. So step by step we will cover all. So in a list we have a first implementation class like ArrayList. So the today topic that we are going to cover is ArrayList, which complete from beginning to till advanced. Okay, how does it work internally, everything we will cover on it. So let's just start. So ArrayList, what it is actually. So ArrayList is same like array only. Okay, which arrays is a kind of way which we don't have any predefined method, right? We have seen that difference between array and collection in the previous recording, right? But in this we will understand ArrayList. So you can think like ArrayList is behave like a same arrays, but it is a predefined class in Java which will give a predefined methods. With the help of them we can perform a number of operations. So we'll understand how does ArrayList work. So ArrayList is a resizable dynamic array. Resizable means the size will not be fixed here. It could be grow and it could be shrink. That we have seen the difference, right? That in a previous recording. Same we have to understand here. It is a resizable dynamic arrays implementation of the list interface. So ArrayList is a child class of list interface. So list interface is a parent of it and ArrayList is a child of it. In Java, it belongs to java.util package. So java.util is one package. Package is nothing like in Java like a folder which will having like collection of classes, right? So util is one package. Inside that package only we have ArrayList class. Unlike normal array which will having a fixed size, ArrayList can grow or shrink dynamically when element are added or removed. So when do we add element or remove element, right? According to that it will grow and shrink accordingly. How to create object of ArrayList? So that is the way we do create the ArrayList object. ArrayList integer list equal to new ArrayList. So what I'm right this time, it is creating a one ArrayList that will add only integers. Okay, we can ignore them as well, but normally that is the right way. We can define any type of it here. Like here I'm creating ArrayList of integer type. That means it will create a one ArrayList that will only store integer value. If you want to store string values, if you want to store any other value, right? So what we will do, we will just change this particular type only. So that means we can define this ArrayList will store that type of element. And we will look at how can we create the ArrayList that can store that different type of element as well. Okay, so whenever we do create this object, ArrayList object this way, right? Then it creates an empty arrays. It creates an empty array. When you add the first element, right, it initializes with the default capacity equal to 10. That means whenever you will create the ArrayList, right, that time what could be the size of it? As in arrays, we do define the size at compile time itself, but in ArrayList, what could be the size? So when you will create the ArrayList like that way, that time the default capacity, right, capacity will be 10 only. That means it can store 10 different elements on it. But what happen if I will store 11th element or 12th element or 13th element? Like if I want to go beyond the 10 element, right? Because the data will come from anywhere, right? There is a dynamic value can be stored inside it. So that time it does use one formula to increase the capacity. What is the formula for that? New capacity equal to old capacity plus old capacity greater than 1. What is greater than 1 called? It is called right shift operator. So how does it work? It does work. First it will calculate what is the old capacity we have. So old capacity we have like 10. So it will calculate the binary of 10. So if we calculate the binary of 10, right, it's a simple decimal to binary conversion. So here it will say that binary of 10 will be 1010. Now here it is writing greater than 1. That means it is saying that right shift, please do the right shift of 1 digit. So when do we do right shift, right? That means this 0 will shift to the left and this element will go to the right. So that means here this 0 will go to the left, right, and this will shift to the left. So here if we will calculate this, right, so that binary will be here 0 1 0. So when we will calculate this binary, that binary will be for 5 only. That binary will be for 5. So here I can say that the old capacity will be 10 plus that it will give me a 5 only here. It will give me a 5 only. So that time I can say that will increase with 1.5 times with older capacity. So the new capacity will be 15 here. So that way whenever it will add that last element, right? So it will calculate or it will create the new capacity accordingly. So that is a formula of increasing the size in array list. Okay, please keep remember them. Okay, so it is a old capacity right shift operator with the one only. So whichever old capacity we have, it will calculate the binary of it, and then only it will right shift of one on, and then whatever the binary will come on it, right, that could be that additional value of it, right? So old capacity value, so this result of this particular calculation will be 5 and old capacity will be the 10, so that means it will be 15, right? So this symbol is called right shift operator. So that way it does grow the size. So that's why here we are saying that it is grow if it is element increasing, shrink if it is element is decreasing, right? So how does it grow? What is the default capacity of array list? That will be the 10, and if you want to store 11th element or 12th element, that time it will calculate this formula to increase the size of the array list, sorry, capacity of the array list. Okay, now let's come to this property of array list. What type of things we can do with the array list? First thing is that array list is order preserved. What is the meaning of order preserve? The order I will add the element, the same order I will get the element, right? We will look in this with the example. Right now you just understand that concepts only. So array list is an order preserve. Null insertion is allowed in array list. That means we can store the null values inside it, right? We can add heterogeneous element in array list. Yeah, we can add heterogeneous. Heterogeneous means different type. Like for example, integer string combination, right? Or it could be any combination. So we can add heterogeneous element into a array list. Array list is not synchronized. That means array list is not thread safe. Synchronized we do use, there is one topic we'll called multi-threading. So in multi-threading we do use this term synchronized very frequently. So okay, so synchronized means the data will not be kind of garbled. So synchronized means we will get the proper data. So that's why we do use this term. So I will explain the terms in detail when we do cover thread concepts. Right now you have to understand that array list is not synchronized or non-thread safe, right? And duplicate element can be added in array list. Yeah, we can add the duplicate element as well, right? So how does it array list work internally? So suppose if you are creating any array list, right? Here I just took example of this one only from 0 to 5, right? So it is a contiguous memory allocation. So that means here it is starting, suppose first element is starting with the zeros. So 0, 1, 2, 3 that you are seeing, right? It is nothing like an index only. It is nothing like an index. And here 1, 2, 3, 5, 3, 6, 4, that is element of it. That means whenever you will add the element on the array list, that will always take a sequential memory allocation, right? So whenever we do add new element, that will again come to the 6th index or 7th index. So that is again one of the important part here, because the one of the data structures will coming after the array list called linked list, which is not a sequential order allocation, right? So that is one of the major part that you have to understand. Array list will always store data into a sequential order. Sequential order means with auto indexing features. So indexing we don't have to worry about it. Automatically that JVM does take care of it, and it will do that auto increment whenever you're going to add the new element on it. That is called sequential memory allocation here. Okay, now let's come to the next thing. Here we are understanding when does it increase the size, or how does it increase the size. Okay, so here we have to understand one thing called load factor versus capacity. So what is a load factor? Other data structures, like which is most popular, I can say set and map. Whenever they do increase the size of it, right, they does use one terms called load factor, right? And in ArrayList or list implemented classes, we do use one terms called capacity. So here we are going to understand what is the difference between load factor and capacity. So in HasMap, we do use load factor, but in list implemented classes, we do use capacity. So when ArrayList does grow that, right? So ArrayList doesn't have a load factor. It is only cares about the capacity versus size. So when does it grow actually? So it is check the size equal to capacity. So the default capacity of ArrayList is a 10 only, right? So size and capacity both are the different. Size means how many element we have inserted on it. Like for example here, what is the size of it? So size will be 1, 2, 3, 4, 5, 6. That means 6 element we have inserted, right? That means that's a 10 size, 6 size of it. What could be the capacity of this array list? that would be the 10 only. That means then can store 4 more element, right? So size means how many number of element is stored inside it, and capacity means what is the default size of it, right? So when they both are equal, size double equal to capacity, then only it does grow, right? If they are not matching, that means it will not grow. Clear it? So when does it grow actually, ArrayList? When does it grow, ArrayList? So when it will match the size double equal to capacity or not. If both are matched, then only it will grow. Otherwise it will not grow. It will keep with the default only. Okay. Now let's understand what is the different type of operation we can perform and what is the time complexity of each and every operation. So as I told, right, even the last recording as well, data structure we have like collection having like n number of data structures, and they are good on some scenario and they are worst in some scenario. So ArrayList is best for in which scenario, that we are going to understand. Okay, so first of all you have to understand, whenever we are going to perform some operation with the ArrayList, we have a different type of operation. First operation will be the get operation. Get means we are going to retrieve from the ArrayList. Add means we are going to add some element on it, or we are going to add with a specific position. So here add element, that means it will go and add at the end only, right? And here it is asked to add with a specific position, like I have like 100 of element. Now here I am saying that please add to the third of position or fourth of the position. So that also we can do it. Same we have a like remove. Remove means it will remove the element from the ArrayList, right? And third last one is a content. Content is performing kind of search operation. Let's say I have one ArrayList where I have some elements. Now I want to search this element is belongs to this ArrayList or not. If it is belongs, fine. If it is not belongs, fine. So content will always return me a boolean value. So this type of operation we can perform with the ArrayList. So get means retrieve. So it will ask the index number of it, which index number you want to retrieve, right? Add element will give that element wherever you want to add the element. Add a specific index, we can do that as well. Remove element, we can remove that as well with a specific index. And contents means it will check the element is present or not. So content is for search operation, add is for add element, remove is for remove element, and get is for retrieve element, right? So here we are going to understand the time complexity. So for get index, it is taking complexity of big O of 1. So how does calculate the complexity? Let's understand that first, then I will come to this part. Okay, so how does calculate the time complexity? So here I have given the simple example. So time complexity is calculated on the basis of running the loop. So here I am running a one loop, suppose for I equal to 0, I less than n, and I plus plus. So that times how many times this loop will run? This loop will run n times. That means, so here I can say the time complexity of this particular loop will be, so here we are using one O. So O is called big O notation. So whenever we are calculating the time complexity, right, we will always use one annotation like big O notation. So big O notation will say that that is the representation of the complexity. So here we are saying big O of n. That means if you want to perform some operation with that, right, it will take n number of iteration. How many number of iteration? N number of iteration. Like for example here I am using nested loop. So we have a loop inside the loop. So for this loop will run n time, and this will also run the n time. So outer loop run n times and inner loop run n times. So for each outer loop, iteration total will be n multiply n. So that means n square. So how many times this loop will run? N square time this loop will run, and the time complexity will be big O of n square. So that way we do calculate the complexity, time complexity. So according to the number of loop only we can decide if it is having n. So you can see here O of n and O of n square, which one run faster. So I can say that the complexity which is having O1, definitely that will take less time, and O of n square will take more time, right? Because it is running the twice of it, I mean square of it, right? So that way we can calculate. If it is having O of 1, like for example this scenario, O of 1, that means in this scenario it will run only one time. So time complexity we do calculate on the basis of running the loop iteration, how many number of iteration is required to perform that operation. If it is taking less number of iteration, we can say that that data structure is best for this particular operation. Like for example here, getting the element O of 1, time complexity will be O of 1. That means it is a much faster because it will take only one iteration. Add element, on a add element we are going to store at end only, right? So amortize with O of 1, but O of n when resizing happen. Like for example, what is the meaning of resizing happen or amortize? Like for example, I am going to add one element at the end itself. Like for example, I created a one array list that is having a 10 size. Now I am going to add the element at 9th position. So that means it will take only one iteration. But whenever you are going to add 11th position, right, that time it will create a new element, new block. So actually that is also one of that things here. When does it grow the size, right? When does it grow the size? How does it grow? So let's say the default capacity of the array list is like 10. So it will create a block of 10, right? So whenever you create the 11th element of it, right, that time it will create the new block of it, and all the 10 element will shift to the new block. So shifting will happen actually here. So according to the capacity, that is a very worst scenario of this ArrayList data structure. Shifting. Whenever you grow the size, that means that will create the new block and that will shift element to the new block. Okay, and add element O of n, shift elements, right, and remove element O of n. So whenever you will add with a specific index, right, that time it will take O of n iteration. That means shifting the element. And for remove also it will take O of n because shifting the element, and contents also will take O of n with linear search operation. So here contents will perform the linear search and that will take also O of n iteration. So for which operation I can get more use for this array list? So I can say that get only. Get means retrieve because it will take only one iteration for that. And remaining other operation it is taking O of n, O of n, O of n. But for one operation only it is taking O of 1. So I can say here only retrieve operation array list is better because it is taking only one iteration. It is taking only one iteration, not taking more than one iteration. So what does it mean? How do we do that all? Let's understand with the examples now. Okay, now let's come to the example. So here I created one example of array list. Okay, so that example we'll understand. So public static void main simple I created ArrayList demo class, and here I kept list equal to new ArrayList. That will also possible. So what happened, right? List is a, so the way I created that object there, right, that was ArrayList L equal to say like new ArrayList, right? So here I am not defining any type. Okay, L will be capital here, ArrayList, right? So here ArrayList L equal to new ArrayList. So that is also creating a one ArrayList object which is having a default capacity is like 10 only, and that is also creating the ArrayList object which is also having a capacity of 10. So both are the way fine. That is a more recommended way. That is a more recommended way because always whenever we have like some interface and having a child class, we do always prefer to create the object by using the parent reference equal to the child object. That is called runtime polymorphism as well. So we are not going to use this one. We can use them, that is not wrong, but that is the right way. That is the right way we can go with that. Okay. So here I created the array list that that will store any type of element. So you can see here I am adding here integers, I am adding null, strings and float values. That means this list array list which I created, right, that are having a heterogeneous type of element. Heterogeneous means integer and strings and float, all type of element we have. So when do we display that, right? What could be the output here? It will give me 123 123 null hello and 345.8. So that way I was saying it is order preserve. Order preserve means what? The order I added the element, the same order I do get the element as well, right? That is the meaning of order preserve. So when I will display this element, I will get every element 123 123 null hello and 345.8. Why I am saying order preserve? Some of the data structures that we will cover later on, right, that will be not order preserve, but some of the data structure is order preserve, right? Now here we are going to get element like 3. So 3 is nothing like an index only. So it will directly go to this particular index and it will give me result. So here it is like hello only. And if you want to remove, we can pass the index only. So it will take 0 1. So this element will be removed here. So 1 2 3 will be removed here. And duplicate also will allow here, right? 1 2 3 1 2 3 is coming twice only. So duplicate is allow, order is preserved. Okay, that all things we have covered it. right? So here we will run this, it will give me complete list. Now contents that plus check, it is performing the simple linear search operation, like linear search operation it will perform right here, and it will check this hello is present inside that or not. If it is present, will perform, otherwise not perform. Now list.size will calculate the size of this particular array list. So how many elements we have? 5 elements, so it will give the size is like 5 only here. So that way we can perform different type of operation with this array list. Now let me run this. So let's start first. So first, when we are going to display here, right, list, so it is giving me 1 2 3 1 2 3 null hello 3 4 5.8, and if you're getting 3, it is giving me a third index, we have like hello only, right? It is removing, so it will remove, right, 1 2 3, it is giving 1 2 3, and here again I am getting the list, so 1 2 3 has removed, so 1 2 3 null hello and 3 4 5.8, right? And here it is giving me true or false answer. So hello we are passing here, right? If it is present, it will give me true. If it is not present, it will give me false. And what is the size of it? The size will be 4 only here. So that way this all operation will work here, right? But if I will go with this specific type, so here I did not define any type. This is not a recommended way. Okay, when you will work on a project, right, that is a not recommended way. We can do it, but not recommended way. Again, I'm saying. So what is recommended way? You have to define a specific type of it. So let's say I want to define it, that could be a string type. Okay, that is a recommended way. So whenever you are creating the array list, right, or any list of objects, any type of object, we have to define a specific type of it. So that means this will store only a string type of element. Now you can see here, whenever we are adding integer element, it has started giving me error, right? It is not allowing that, and here also it is not allowing that, because that is a float value. The previous scenario it was allowing it, but now it is not allowing. So let me comment that. Okay, so this is not allowed here. Only a string can be allowed, rest cannot be allowed. Okay, so here if you all pass integer, that will say integer type only allow, string type, string is all allow. That is called generic type. So list is a generic, can be store any type of element, right? So if you will not pass here that any type, it will store any type of element, which is not recommended way. Recommended way is that whenever you are creating the list, then you have to define a specific type of element which it can be stored, right? So that is all about the bit of the list data structure, ArrayList data structures, where we have covered everything regarding the performance. So some of the question will come, what is the difference between array and ArrayList? So array is like a normal data structure. Normal means it is not a predefined class in Java, right? If you want to perform any operation with the arrays, we have to do that manual operation, as well as arrays are a fixed size, right? And it is having a static size, all right? And ArrayList is a predefined class which is having a different methods. Like for example, we can see here, right? Get method, remove method, right? Get content method, size method, which can be perform some operation with the efficient way that array cannot do that. Array can do that, but we have to write the logic for it, right? But in ArrayList, we don't have to write the logic for it. We have to just call that method. So these are difference. And ArrayList is better for which operation? ArrayList is better for which operation? Let me show you that as well. ArrayList is better for which operation? That we can find in the terms of complexity. So for which complexity, for which particular operation it is taking less time. So for get operation, it is taking only one iteration, right? It is taking one iteration. That is also one of the major point here. ArrayList is better for retrieve operation because it does take one number of iteration. For rest of the operation, it does take n number of iteration. So that is not recommended way. So if other data structure who can take one iteration for add, remove and content, add, remove and search operation, we do use that data structure for that particular purpose. So right now it is the first data structure, right? ArrayList. Later on will come linked list, vector, set, queue, right? So we'll see that for what operation ArrayList vector, linked list vector or set or queue or map will be better. So for that right now that I can say we can perform all type of operation, no problem. But for which operation it is the best performance will give ArrayList. So that will give best performance in terms of retrieve operation, not like for other operation. So that is the main use of ArrayList here. So that is a way of calculating the complexity. I told you how does it calculate the complexity. Okay, so these are the different type of operation we have seen on this ArrayList from beginning to till advanced, calculating the size and everything on it. One more thing I want to tell you here, ArrayList does implement some interfaces. These are predefined interfaces that you have to understand. Okay, that is also one interview questions. How many interface does implement by the ArrayList? So ArrayList is implement 3 different interface: random access that will give you fast fetch operation, clonable, we can create the clone of it, and serializable. So these are the 3 different interfaces. These all perform different type of operation. Cloning means if you want to create the clone of your object, that we can use. Random access for retrieve operation. Serializable means whenever you're transferring that over the network. So serializable terms we will use whenever we are transferring this objects over the network, then we can use them, right? So random access, clonable and serializable, these are the 3 interfaces that will implement by the ArrayList. Okay, so these are the last thing that we have to cover on it.